Hi, my name is Quang Nguyen, and I'm going to talk about my research project on modeling and predicting English Premier League goal scoring. So first, some background is what we're trying to do here. So this project consists of two big ideas. The first one was to determine the consistency between properties of goal scoring in the Premier League and key distributions of the Poisson process. They are the Poisson distribution, the exponential distribution, and the uniform distribution. And our second goal was to utilize the method of Poisson regression to predict outcomes for a Premier League season. And this involves some simulations as well as analyses and comparisons of various soccer metrics. So first, let's talk about the Poisson process. So suppose we are interested in counting how many events will take place in a specified amount of time or space. So this gives rise to a stochastic process over a continuous time interval. And this process is called the Poisson process. And playing a huge role in this Poisson process are the following probability distributions. So we have the Poisson distribution, which measures the number of occurrences of an event in a given time period, like the number of goals per match. Next up, we have the exponential distribution, which describes the waiting time between the events. It's like time between goals in a Premier League season. And lastly, we have the uniform distribution, which illustrates the time locations of events. For instance, time positions of goal in a match. So now, before we move on to our findings, let's quickly introduce the data that we're using for this project. So here we have two data frames. The first one, as you can see right here, consists of all final scores from 1992, 93 to 2018-19, and we use that one to look at the number of goals scored. So basically these two columns. And our second data contains scoring time for all Manchester United goals in 2018-2019 season. And for this one, we were interested in looking at the minutes or the time of goals, as well as the time between goals. Now, onto our findings. So first, we look at the Poisson distribution and number of goals. And here we're looking at the Poisson expected counts for these goal values. So 0, 1, 2, 3, and 4 or more. And comparing them with the actual observed matches, having those goals in real life. And so here's a bar plot of comparing the theoretical and predicted number of matches. And as you can see, the fit looks great. And so we would like to use a chi-square goodness of fit test to confirm this fit. So a goodness of fit test assumes that the data follow a specified distribution, like in our case, it's Poisson. And chi-square is the right test here since it is useful when data has been counted and divided into categories like these right here. And here are our test results, and we can conclude that our assumption of consistency between the distributions was not rejected. So as mentioned before, we also wanted to verify the fit between our data and two other distributions. They are exponential and uniform. And so we plotted the empirical distribution of the data and the cumulative distribution of the reference distributions. So here we have one for time between goals and exponential. And here we have rescaled time of goals and the cumulative distribution for the uniform distribution. And real quick on rescaling the time. So we did that due to the fact that in soccer, some matches take place longer than others because of stoppage time. So we were able to handle that small issue by just rescaling the time variable. And this time, our relationships were confirmed by a Kolmogorov-Smirnov test. And this test is appropriate here since we have continuous data. And so here are our test results for these two tests. And so overall, since we have all the fits for all of our three relationships, we can say that the Poisson process is appropriate for modeling goal scoring in the Premier League. Now, on to our second topic, which is Poisson regression. So, Poisson regression is used to model response variables that are counts and follow a Poisson distribution, like number of goals. And so we fitted Poisson regression models to get the expected scoring rates for every team at home and on the road. So as you can see right here, those are this one and this one, these two columns, those are the rates that I was talking about. And we use those rates to execute our simulations. So we basically randomly generated how many goals each team has in every matchup. So those are the scores of every matchup. And so we did a total of 10,000 simulations, and we did that for three different subsets of data. Data for all seasons prior to 2018-19, since we were interested in predicting what would happen in that year from prior data, and then data from only the 2010s, and lastly, we have data from all seasons, but we assign weight toward more recent years. And so here is a sample simulated league season table out of the 10,000 that we got from our simulations. And we got a bunch of results, of course. And I picked these two tables. So those are the chances of winning the title and getting relegated after the 2018-19 season. And so I just wanted to highlight one quick thing here. So if you look at this first table for Manchester United, if we use all seasons to predict their chances of winning, they got about a 37% chance of winning. But if we just focus more on more recent data, then their chances dropped significantly down to about 10.5%. This actually quite makes sense because in real life, United used to be really good in the past, but recently, over the past 7 or 8 years or so, they haven't been doing really well. So, yeah, that helps explaining this drop off. And last but not least, here are some possible future work as well as applications of this project. So in the future, we could try to account for more soccer variables, such as clean sheets, and then number of corners, or even possession times or winning streaks. And we can use all of them to find a predicted model for goal scoring. We can also try to factor in some organizational changes, such as whether a team has a new coach or a new owner or new players. And we can also calculate win probabilities based on what we got for our simulations, and we can use those to and we can eventually convert those into betting odds. So that's all I have. This project was actually my senior honors thesis at my undergraduate institution, Windward University in Springfield, Ohio. And my advisor was Dr. Doug Andrews, so a big thanks to him. I've also included my email here, so feel free to drop me a line for questions or feedback on this project. And here are also two links. One is for the full version of this project report, and this one is for the some of the codes I put on GitHub, so feel free to check them out. And I hope you enjoy my presentation, and thank you for listening.